Hey everyone. I've just finished watching the phenomenal discussion between Lex Friedman and Jan LeCun. And in this video, I wanted to share some of the insights and some notes on what they discussed, particularly on the topics of large language models and the limitations of language-based representations, and also what hierarchical planning is and how that relates to autonomous agents. So I've got my write-up here on the screen and we're just going to go through this article together. I put the link to the article in the description box below, so you can also go check that out on my Medium account. So let's get right into the video. In this article, we're going to be examining the constraints of language in AI and analyze the role of hierarchical planning in developing autonomous AI. The limits of language. We perceive the world through our senses, forming mental models of our surroundings. Our brain is capable of aggregating data from our sensory inputs to form an abstract representation of our reality. So using our senses, which are our taste, touch, smell, hearing, and vision, using those senses, we are able to form a mental model in our head of what our current reality is. Now, language is not actually one of these senses, but it's a medium through which we communicate these perceptions. It serves as a high-level, compressed information system, derived from lower-level modalities, such as tactile input, emotions, visual data, and others. Now, we've all heard the saying, a picture is worth 1,000 words. But what does this mean in the context of information gain? Images and videos convey information more efficiently and richly than text, and they provide deeper and higher quality representations. The image of the world around us, which we carry in our heads, is just a model. Nobody in their head imagines all the world, government, or country. They have only selected concepts and relationships between them, and use those to represent the real system. So this diagram is showing us that our human brain is actually prioritizing visual data over textual data. And you can see visuals are processed 60,000 times faster than text. And 90% of the information transmitted to the brain is visual in nature. So you can see the difference between language and visual data such as images and videos. Language is a very compressed and high-level information system, whereas images and audio are low-level and they contain a lot more information. The bottlenecks of current artificial models. Present-day large language models analyze vast chunks of linguistic information. However, there is a limit to the amount of reasoning capability you can extract from language. And besides, the seemingly massive volume of data is nothing compared to the data we input daily through perceiving the world around us. And Jan LeCun has this famous quote, which is, "A child has seen 50 times more data than the large language models that are trained on the totality of all text that is available now." So you can imagine the scale of the data that humans are able to consume and analyze compared to the data that large language models are currently being trained on. So how do we learn higher quality representations? Future AI systems will be able to integrate even larger datasets of diverse data. And by diverse data, I mean that the datasets will not just be focused on language. The datasets will contain information on images, audio, video, and so many other modalities. So this will enable the single model to achieve low-level abstract reasoning. And such a model should be able to express its reasoning in terms of these different modalities. So it shouldn't matter whether you give the model a language input, an image input, a video input. It should be able to analyze all of that data on the same abstract reasoning, on the same level of abstract reasoning. And it should be able to output a response which is compatible with the output response that we want. So it could be output of language, video, images, or audio. To accomplish this, we must revisit our approaches to utilizing non-linguistic data for extracting valuable representations. And this will likely require innovations in model architectures and training methodologies. So I have some architectures here, and actually one of the architectures that was actually proposed by Jan LeCun is the IJEPA architecture. And the idea behind IJEPA is to predict missing information in an abstract representation that's more akin to the general understanding people have. So instead of predicting missing information on the data itself, such as the images or the text, the IJEPA model is going to predict missing information in the abstract representation itself. So here are some common architectures for training these models currently. And the similarities between each architecture is that we have some input X and some output Y, and we're trying to learn a distance function between these two variables, the input X and the output Y. And we want to compute a distance function such that when X and Y are similar, the distance function should produce a low value, and when X and Y are different, the distance function should produce a high value. And this is also called energy, and an energy model. So the objective is to assign a high energy to incompatible inputs and to assign a low energy to compatible inputs. So these don't necessarily have to be input and output per se, they just need to be like related items or unrelated items. So the takeaway from this section of the article is that language is a very compressed and very limited form of information. To create really intelligent and truly autonomous AI systems, we will need to utilize image, video, and audio data much more heavily so that these models can actually learn a better representation and higher quality representation of the world around it. Now let's dive into hierarchical reasoning. Hierarchical reasoning is a cognitive process where an entity, whether human or artificial, decomposes a broad goal, action, or piece of information into a structured sequence of smaller, more manageable parts or layers. This decomposition facilitates understanding, planning, and problem solving by establishing a clear, tiered framework that simplifies complex concepts or tasks. And here is an image, it's just an example of what hierarchical reasoning looks like. So we start at the somatosensory, which just means body sensory inputs, and basic sensation, muscular movements, vibrotactile, and prosodic features. And prosodic features just means like rhythm, tone, pitch, things like that. And then each level we move up, we add an abstraction of reasoning. So the next level up is gesture, voice, food, and emotions. The next layer is drawing, passive viewing, motion, rotation, expectancy. The next layer is memory, math, deception, and faces. And the final layer is the most abstract layer, which is reasoning, naming, concepts, language, and imagination. And this is just an example of what a hierarchical structure of abstract reasoning would look like. I think it would be useful if we went through an example of what this hierarchical reasoning could look like. And to illustrate this, I'm going to take the example of taking a trip from New York to Paris. This is a relatively complex procedure with a lot of moving parts, but we can break it down into a sequence of layered tasks. So the task is to go from New York to Paris, but this task can be broken down into 3 subtasks, which are booking a flight to Paris, driving to the airport, and then taking the flight to Paris. Now, each of these subtasks can be further broken down into their own subtasks. So booking a flight to Paris could include opening a browser, searching for a travel agency, and purchasing the flight to Paris. Driving to the airport could include exiting the house, setting up a Maps app, starting the car, and following directions to the airport. And taking the flight to Paris could include entering the airport, entering the plane, booking a hotel, and of course a lot more. And this is just a very simplified plan for how you would go from New York to Paris. Now, while we could have theoretically dissected each step down to the level of individual muscle movements, and eventually we would go down to quantum field theory, but such detailed breakdowns aren't practical, or they aren't even how human minds typically operate. We don't visualize every single granular detail all the way to quantum field theory whenever we're trying to do something. But we conceptualize broader steps and underlying relationships to navigate the reality or the current task. On our trip from New York to Paris, we don't meticulously plan every single muscle movement we're going to take. Rather, we form a basic abstract strategy. Yet without some sort of hierarchical planning, executing such a journey or any complex task would be unattainable. For artificial entities to achieve true autonomy, they must possess some key abilities: discerning and transitioning between different layers of abstraction and reasoning, and they must possess the necessary tools for executing that specific task, which will likely arise from advancements in robotics. That's all for the video today. I hope you enjoyed, and hopefully you learned something new about how language is limited in providing detailed representations, and also what hierarchical planning is and why agents might need to utilize hierarchical planning. This video was based on Jan LeCun and Lex Friedman's discussion, and I sort of took some of the points from that discussion and elaborated on them. So if you like this video, you'll definitely enjoy the podcast if you've not already watched it. So I'll put the link to that in the description box below, so you can go ahead. It's really a fun talk, and Lex Friedman does a bunch of great talks, and I think his discussions are very insightful, and he gets a lot of great perspectives as well. So definitely go check that out. That's a wrap for this video. If you liked it, go ahead and smash that like button, and don't forget to subscribe so you get updated when I post new content. Let's wrap up the video here, and I'll see you in the next one. Peace.